Spring Boot architecture. Here you can see Spring Boot flow architecture. Java Spring Boot is a tool that makes developing web application and microservices with Spring Framework faster and easier through three core capabilities. 1. Auto configuration. 2. An opinionated approach to configuration. 3. The ability to create standalone applications. These features work together to provide you with a tool that allows you to set up a Spring-based application with minimal configuration and setup. Here you can see Spring Boot architecture. Spring Boot has a layered architecture in which each layer communicates with the layer directly below it and above it. Presentation layer. This layer processes the HTTP request from client, converts JSON message body to objects and handle authentication of the request before transferring it to the business layer. It's also handles presenting the views to the client. Business layer. This layer encompasses the business logic in the application. It performs the validation and authorization of the request and has several service classes. These service classes then interact with the data access layer, persistence layer. This layer converts the objects in the application to the database rows objects using the storage logic. Database layer. This is the layer in which the data is data required by the application is stored, and on which CRUD, create, read, update, delete operations are executed. Here you can see a presentation layer, authentication and JSON translation is inside presentation layer. Presentation layer interacts with business layer. Business logic, validation and authorization are inside the business layer. Business layer interacts with persistence layer. Storage logic is inside persistence layer. Persistence layer interacts with database layer. Actual database is inside database layer. Now we are focusing on client. The client makes an HTTP request, get, put, post, etc. As an example, we can consider creating a new application. To generate the project from command line, you can use curl starting from an empty directory. To get start with Spring Boot and client-side development, let's start at the beginning with an empty app from Spring Initializer. You can go to the website and download the project with web dependencies, select web flux or WebMVC and open it up in your IDE. Or to generate a project from command line, you can use curl starting from an empty directory. We can add a really basic static home page, for example at source main resources statics index.html, and then run the app and you can see the result on localhost colon 8080. In the browser it look like this. Here codes for tabs are omitted. As an example too, we are considering dynamic content with HTMX. Then we can change the greeting from hello world to something that comes from user input. Let's add an input field and a button to the main tab. We can add some dynamic content really quickly with HTMX. First, we need the JavaScript library, so we add it as a webjar and the dependency, and then import it in the index.html. Then we can change the greeting from hello world to something that comes from the user input. Let's add an input field and a button to the main tab. The input field is unadorned, and the button has some hx dash asterisk attributes that are grabbed by the HTMX library and used to enhance the page. This one say when a user click on the button, send post to /greet, including the name in the request, and render the result by replacing the content of the greeting. If the user enters foo in the input field, the post has the form encoded body of value equal foo, because value is the name of the field identified by hash name. Then all we need is /greet resource in the backend. Spring will bind the value parameter in the incoming request to the greeting. And we can we convert it to the text, which is then injected in the div id equal greeting on the page. You can use HTMX to inject plain text like this, or whole fragment of HTML, or you can append or prepend to a list of existing element like rows in a table or items in a list. Here this one is not directly related to this code. This is with the get to with the get request. When the page loads and swap the content of the elements, and the sample app has this endpoint here, and it returns Fred. So you see it rendered like this. So Fred is entered in the text box, and this is for a varied code from here. But here you can see the greet button and text and input here. As an example 3, we are considering dynamic content with hotwired. Here is the test tab in index.html. Hotwired is a little bit similar to HTMX. So let's replace the libraries and get the app working. Take out HTMX and add hotwired turbo to the application, and in pom.xml file, and add the dependency. We can import it into our page by adding import map and a script to import turbo from a script to import the library. This lets us to do dynamic content stuff that we already did with HTMX, with a few changes to HTML. Turbo works a little differently than HTMX. The turbo frame tells turbo that everything inside is enhanced, a bit like HTMX boost. And to replace hello and world elements on a button click, we need the button to send post uh, through a form, not just a plain get. Turbo is more opinionated about this than HTMX. Uh, the /test endpoint then send back some turbo stream fragments containing templates with the content we want to replace. The /test endpoint then send back some turbo stream fragments containing templates with the content we want to replace. To make turbo take notice of incoming turbo stream, we need the /test endpoint to return a custom content type text /vnd.turbo-stream.html. So the implementation look like this here. To serve the custom content type, we need a custom view resolver. Here is a copy of the being defined automatically by Spring Boot, but with an additional supported media types. There is an open feature request to allow this to be done via application.properties. The result of clicking fetch button should be to render hello and world as before. Now we are considering at some charts as example 4. Here a new tab in index.html. Remember to add the NAV link as well. We can have some fun adding other JavaScript libraries, for instance, some nice graphics. Here's a new tab in index.html. Remember to add the NAV link as well. It has an empty canvas that we can fill with a bar chart using chart.js. In preparation for what we declared a controller called chart in HTML here, and label the target element for it with data dash asterisk dash target. So let's start by adding chart.js to the application in POM XML at the dependency, and in index.html we add the import map and some JavaScript to render the chart. And the new controller implementing bar and clear actions from the buttons in HTML. To serve this, we need /pops endpoint with some chart data, estimated world population by continent according to Wikipedia here. The sample app has few more charts, for example, all showing the same data in the different formats. They are all serviced by the same endpoint. Now we are focusing on code block hiding. Here's what it looks like. In Spring guides and reference documentation, we often see blocks of code segmented by type. For example, Maven versus Gradle, or XML versus Java. They are shown with one option active and the rest hidden. And if the user click on another option, not just one closed code snippet, but all the snippets in the whole document that match the click are revealed. For example, if the user click on Gradle, all the code snippets that refer to Gradle are simultaneously activated. The JavaScript that drives that feature exists in the several forms depending on which guide or project is using it, and one of those forms is an npm bundle at Spring IO/utils. It's not strictly an ESM module, but we can still import it and see the feature working. Here's what it look like in an index.html. And then we can add a new tab with some code snippets. Just link content in this case. It look like this if the user selects one block type. The thing that drives the behavior is the structure of the HTML with one element label primary, and alternatives as secondary, then a nested class title before the actual content. The title is pulled out into the buttons by the JavaScript. As an example 6, we are considering view, the dynamic content with view. To receive dynamic content, we need an element that matches hash event dash handling. Vue is a lightweight JavaScript library that you can use a little of or a lot. To get started with WebJAS, we would need the dependency in pom.xml. So add the dependency there, and add it to the import map in index.html using manual resource path, because the module in npm bundle points to something that doesn't work in a browser. Then we can write a component and mount it in a named element. It's an example from Vue user guide. To receive the dynamic content, we need an element that matches hash event handling, for example. So here's the hash event handling here, and here. So the templating happens on the client, and it is triggered by a click using v-on from Vue. As an example 7, we are considering plain JavaScript with SSC stream. Here's a stream tab. Vue isn't really adding a lot of value in this simple HTML replacement use case, and it would add no value at all to the SSC example. So we will go ahead and implement that vanilla JavaScript. Here's a stream tab and some JavaScript to populate it. As an example 8, we are considering dynamic content with React. It is attached by React DOM to an element with id equal root. So we would better add one of those as well. For example, in the test tab. Most people who use React probably do more than just a bit of logic and end up with all of the layout and rendering in JavaScript. You don't have to do that, and it's quite easy to use just a bit of React to get a feel for it. You could leave it at that and use it as a utility library, or you could evolve to a full JavaScript client-side component approach. We can get started and try it out without changing too much. Sample code will end up looking like a React-WebJS sample if you want to pick. First, the dependencies in pom.xml file, add those dependencies, basically React and React-DOM, and add the module map in index.html. React is not packaged as an ESM bundle yet anyway, so there is no module metadata, and we have to hard code the resource path like this. The UMD in the resource path refers to universal module definition, which is an old attempt at modular JavaScript. It's close enough that if you squint, you can use it in a similar way. With those in place, you can import the functions and objects they define. Because they are not really ESM modules, you can do this at the global level. A script in HTML head. For example, where we import Bootstrap, then we can define. Then you can define some content by creating a React component. Here's really basic static example. The renderer method returns a function that creates a new DOM element and h1 with content hello world. It is attached by React DOM. To an element with id equal root. So we would better add one of those as well. For example, in the test tab. If you run this, it would work and it should say hello world in that tab. As an example 9, we are considering rollup.js and building with rollup. This is rollup.config.js. The Bootstrap maintainers use rollup to bundle their code, so that seems like a decent choice. One thing it does really well is tree shaking to reduce the amount of JavaScript you need to ship with your application. Feel free to experiment with other tools. To get started with rollup, we need some development dependencies in package.json and a new build script. So add those packages: rollup plugin not resolve and rollup and rollup. Rollup has its own config file. So here one that with the bundle local JavaScript resource into an app and serve the JavaScript up for /index.js at runtime. This is rollup.config.js. So if we move all the JavaScript into source main JS index.js, we would have just one script in index.html, for instance, at the end of the body. So in index.js, we have all the script tag contents mushed together, or we could have split it up into modules and import them. If we build and run an app, run the app, it should work. It should all work. And rollup creates a new index.js in target classes static, where it will be picked up by the executable jar. Because of the action of the resolve plugin in rollup, the new index.js has all the code that is needed to run our application. If any dependencies are packaged as a proper ESM bundle, rollup will be able to shake the unused parts of them out. It worked for hotwired stimulus at least, and most of the other get included wholesale, but result still come up. As an example 10, we are considering building a React app with Node.js. We will need React dependencies and also build time tooling for Babel. Here is what we end up with. To finish, we can apply this same ideas to React -webjar sample, removing webjars and extracting JavaScript and CSS into separate source files. This way we can build we can also finally get rid of this slightly problematic at Babel /standalone. We can start from React-webjar sample and add the front-end plugin as here, and create a package.json. either manually or via the npm CLI. We will need the React dependencies and also the build time tooling for Babel. Here's what we end up with. We need common JS plugin because React is not packaged as an ESM, and the import will not work without doing some conversion. The Babel tooling comes with the config file.babel.rc, which we use to tell it to build the JFX and React components. With those build tools in place, we can extract all the JavaScript from index.html and put in src main resources static index.js. It's almost a copy paste, but we will want to add the CSS imports. And imports from React look like this. You can build that with npm run build or /menw generate dash resources, and it should work. All the tabs have some contents, and the buttons generate some contents. Finally, we just need to tidy up the index.html so that it only imports the index.js and index.css, and then all features from the WebJars project should be working. As an example, we can consider this one, timestamp and bad request, JSON parse error. Now we are focusing on controller. The HTTP request is forwarded to the controller. The controller maps the request. It processes the handles and calls the server logic. The JSP page is returned as a response from the controller. Here you can see the flow chart. We already know that the control is very much required in the web application to handle HTTP request from the client. To handle this request, we use the controller in Spring Boot. The control is nothing but just a normal class annotated using the @REST controller. This annotation tells that this is a controller, and inside this we can write our different HTTP points which are required. In this we will see the internal working of the control, especially in Spring Boot, with one flow diagram here. Here in step 1, in Spring Boot, first we receive HTTP request from the external source or client side. First it will go to the dispatch servlet. Step 2, in this step, now the dispatch servlet will try to find out the respective controller for this HTTP request with the help of handler mapping. After knowing the controller name which can handle the request, the dispatch servlet will transfer that request to the respective controller. In step 3, now the controller will process the request based on the parameter and URL mapping on the HTTP request, and after performing the business logic, it will return the response as JSON XML to the client. Step 4, this is how it works in general, but in Spring MVC we have a view resolver, but here in Spring Boot we do not have it because we do not render the view. In return, we just simply send the JSON or XML as the response to the client. Here you can see external interacts with dispatch servlet. Dispatch servlet is connected to handler mapping. Handler mapping is connected to controller. Controller interact with model view, and controller is connected to dispatch servlet. And here the dispatcher servlet is connected to external. Here you can see Spring Boot REST API workflow. So here we can quickly go through the workflow of Spring Boot workflow, how Spring Boot handle REST API request and processes and returns the response. First, the request is received by the dispatcher servlet, which is responsible for processing any incoming URL URI request and mapping them to the corresponding handlers in the form of controller methods. After controller methods has been executed, then the resource is then processed as a response, which can either be JSON or XML. In this diagram, two processors encapsulated in the rectangle are the processes actually implemented by a developer. REST the rest are executed by Spring services that are running in the background, including dispatcher servlet. Here you can see a dispatcher servlet intercept the request is connected to map request URI to a controller method. Map request URI to a controller method is connected to execute controller method. Execute controller method is connected to build response entity. Build response entity is connected to convert response entity to the type specified by request. Convert response entity to the type specified by request is connected to return response to the client server making the request. As an example, we are considering this one here with related to writing the code. By default, Maven compiles sources from source main Java, and so you need to create that directory structure and then add a file named src main Java my application Java my application.java to contain the following code. Although there is not much code here, quite a lot is going on. We step through the important parts now. The REST controller and at request mapping annotations. The first annotation in our my application class is at REST controller. This is known as a stereotype annotation. It provides hints for people reading the code, and for Spring that class plays a specific role. In this case, our class is a web controller, web at controller. So the Spring considers it when handling incoming web requests. the at request mapping annotation provide routing information. It tells Spring that any HTTP request with the path / should be mapped to the home method. The at rest control annotation tells Spring to render the resulting string directly back to the caller. The at rest controller and at request mapping annotations are Spring MVC annotations. They are not specific to Spring Boot. The at Spring Boot annotation. The second class level annotation is at Spring Boot. The at Spring Boot application annotation. The second class level annotation is at Spring Boot application. This annotation is known as a meta annotation. It combines at Spring Boot configuration, at enable auto configuration, and at component scan. Of those, the annotation we're most interested in here is at enable auto configuration. At enable auto configuration tells Spring Boot to guess how you want to configure Spring based on the jar dependencies that you have added. Since Spring Boot starter web added Tomcat and Spring MVC, the auto configuration assumes that you are developing a web application and sets up the Spring accordingly. The auto configuration is designed to work well with starters, but the two concepts are not directly tied. You are free to pick and choose jar dependencies outside of these starters. Spring Boot still does its best to auto configure your application. The main method. The final part of our application is the main method. This is a standard method that follows the Java convention for an application entry point. Our main method dedicates to Spring Boot's Spring application class by calling run. Spring application bootstrap our application starting Spring, which is in turn starts the auto-configured Tomcat web server. We need to pass myApplication.class as an argument to the run method to tell Spring application which is the primary Spring content, primary Spring component. The args array is also passed through to expose any command line arguments. As an example 2, we are considering the Spring Web MVC framework in servlet web applications. The Spring Web MVC framework, often referred to as Spring MVC, is a rich model. Is a rich model view controller web framework. Spring MVC lets you to create a special at controller or at rest controller beans to handle incoming HTTP request. Methods in your controller are mapped to HTTP by using at request mapping annotations. The following code shows a typical REST controller that serves JSON data. The web MVC.fn, the functional variant, separates the routing configurations from the actual handling of requests. As shown in the following example. Spring MVC is a part of the core Spring framework. You can define as many router functions beans as you like to modularize the definition of the router. Beans can be ordered if you need to apply precedence. As an example 3, we are considering the Spring Web Flux framework in reactive web applications. The annotation based one is quite close to the Spring MVC model as shown in the following example here. Spring Web Flux is new reactive web framework introduced in Spring Framework 5.0. Unlike MVC, it does not require the servlet API, is fully asynchronous and non-blocking, and implements reactive streams and streams specification through the Reactor project. Spring Web Flux comes in two flavors, functional and annotation based. The annotation based one is quite close to the Spring MVC model as shown in the following example. Webflux.fn, the functional variant, separates the routing configuration from the actual handling of the requests as shown in the following example. The Webflux is part of the Spring framework, and detailed information is available in the reference documentation in Spring. You can define as many router functions beans as you like to modularize the definition of the router. Beans can be ordered if you need to apply a precedence. To get started, add the Spring Boot Starter Web Flux module to your application. Adding both Spring Boot Starter Web and Spring Boot Starter Web Flux modules in your application results in Spring Boot auto configuration is Spring MVC, not Web Flux. This behavior has been chosen because many Spring developers add Spring Boot Starter Web Flux to their MVC application to use the reactive web client. You can still enforce your choice by setting the chosen application type, Spring application dot web set web application type dot reactive. As an example, we are considering error handling in the Spring Web MVC framework in servlet web applications. By default, Spring Boot app provides an /error mapping that handles all errors in a sensible way, and it is registered as a global error page in the servlet container. For machine clients, it produces a JSON response with details of the error, the HTTP status and the exception message. For browser clients, there is a white label error view that renders the same data in HTML format to customize it and add a view that resolves to error. There are a number of server.error properties that can be set if you want to customize the default error handling behavior. To replace the default behavior completely, you can implement error controller and register a bean definition of that type, or add a bean of type error attributes to use the existing mechanism but replace the contents. The basic error controller can be used as a base class for a custom error controller. This is particularly useful if you want to add a handler for a new content type. The default is to handle text /HTML specifically and provide the feedback fallback for everything else. To do, extend basic error controller, add the public method with @request mapping that has a produces attribute and create a bean of your new type. As of Spring Framework 6.0, RFC 7807 problem details is supported. The Spring MVC can produce custom error message with the application /problem plus JSON media type, like here. This support can be enabled by setting spring.mvc.problemdetails.enable to true. You can also define a class annotated with @controller advice to customize a JSON document for a particular controller and or exception type, as shown in the following example. In this example, if my exception is thrown by a controller defined in the same package as some controller, a JSON representation of the my error body POJO is used instead of error attributes representation. Here we are considering error handling in Spring Web Flux framework in reactive web applications. Applications can ensure that exceptions are some exceptions are recorded with the request matrices by setting the handle exception as request attributes. For more complete picture, you can also subclass default error web exception handler directly and override specific methods. In some cases, errors handled at controller or handler function level are not recorded by the matrix infrastructure. Applications can ensure that such exceptions are recorded with the request matrices by setting the handle exception as a request attributes. Spring Boot provides a web exception handler that handles all errors in a sensible way. Its position in the processing order is immediately before the handlers provided by Webflux, which are considered last. For machine clients, it produces a JSON response with details of the error, the HTTP status, and exception message. For browser clients, there is a white label error handler that renders the same data in HTML format. You can also provide your own HTML templates to display errors. Before customizing you can leverage the RFC 7807 problem detail support in Spring Webflux. Spring Webflux can produce custom error messages with application /problem plus JSON media type like here. This support can be enabled by setting spring.webflux.problemdetails.enable to true. Here we are considering error example in Spring Boot with Spring Boot support. We are doing the what we are doing is to define the public method using the @request mapping and stating it produces an application /XML media type. The class basic error controller, basic global error at controller, rendering error attributes. More specific errors can be handled either using Spring MVC abstractions, for example at exception handler, or by adding servlet error pages. This is in the package org.spring framework.boot.autoconfigure.web.servlet.error. For example, imagine we want to customize how application handles error triggered in XML endpoints. All we have to do is to define the public method using @request mapping and stating it produces an XML for application /XML media type. Here we are still relying on the server.error. Boot properties we might have been defined in our project, which are bound to the server properties bean. Now we are focusing on service layer. The business logic is performed in the service layer. As an example, we are considering this code. We are considering Spring Beans and dependency injection. If a bean has more than one constructor, you will need to mark the one you want Spring to use with auto void. You are free to use any of the standard Spring framework technique to define your beans and their injected dependencies. We generally recommend using constructor injection to wire up dependencies and component and at component scan to find beans. If you structure your code as suggested above, locating your application class in a top package, you can add at component scan without any arguments, or use the at Spring Boot application annotation, which implicitly includes it. All of your application components at component, at service, at repository, at controller, and others are automatically registered as Spring Beans. If a bean has here the this example shows at service bean that uses constructor injection to obtain a required accessor bean. If a bean has more than one constructor, you will need to mark the one you want Spring to use with auto void. Notice how constructor injection lets the risk accessor field to be marked as final, indicating that it cannot be subsequently changed. As an example too, we are considering the service layer. Here the employee here we are considering service layer. Notice that the DAO interface will be referenced from the service. DAO layer's main goal is to handle the details of the persistence mechanism, while the service layer stands on top of it to handle business requirements. Notice that the DOA interface will be referenced from the service. Here the service is a named component. We will use the name to reference the bean from the JSF context. Here this class has a session scope which will be satisfying for the simple application here. Since Spring built-in scopes have a different model than JSF, it's worth considering defining custom scope if we use JSF sometimes. details omitted here. Here we are considering another example, the employee service IMPL in creating service layer. Here let's create an employee service IMPL class that implements the employee service interface. Here you can see, let's create an employee service interface with CRUD methods. Employee service IMPL. Let's create an employee service IMPL class that implements the employee service interface. Now we are focusing on repository class extending CRUD services. Repository class extending CRUD services. Here you can see Spring Data Repository interface. CRUD repository. There is an interface available in Spring Boot named as CRUD repository that contains method for CRUD operations. It provides generic CRUD operation on a repository. It is defined in the package org.springframework.data.repository, and it extends the Spring Data Repository interface. If someone wants to use CRUD repository in Spring Boot application, he or she has to create an interface and extend the CRUD repository interface. JPA repository. JPA repository is a JPA Java Persistence API, Java Persistent API or Jakarta Persistent API specific extension of repository. It contains full API of CRUD repository and paging and sorting repository. So it contains API for basic CRUD operations and also API for pagination and sorting. Here in this image, repository, CRUD repository, and pagination and sorting repository belong to Spring Data Commons. whereas JPA repository belongs to Spring Data JPA. We can also consider the difference between CRUD repository and JPA repository. In CRUD repository, it is a base interface and extend repository interface. In JPA repository, it's extend paging and sorting repository that extend CRUD repository. Here in CRUD repository, it contains methods for CRUD operations. For example, save method, save all method, find by ID method, find all method, etc. In JPA repository, it contains full API of CRUD repository and paging and sorting repository. For example, it contains flush method, save and flush method, save all and flush method, delete in batch method, etc. along with the methods that are available in CRUD repository. In CRUD repository, it doesn't provide method for implementing pagination and sorting. Here in JPA repository, it provides all the methods for which are useful for implementing pagination. In CRUD repository, it works as a marker interface. In JPA repository, it extends both CRUD repository and paging and sorting repository. In CRUD repository, to perform CRUD operations, define repository extending CRUD repository. Here in JPA repository, to perform CRUD as well as batch operations, define repository extend JPA repository. Here the interface repository, central repository marker interface captures the domain type to manage as well as the domain type's ID type. General purpose is to hold type information as well as being able to discover interfaces that extend this one during class path scanning for easy Spring Bean creation. This is in the package org.springframework.data.repository. Interface CRUD repository TID. Interface for generic CRUD operations on a repository for a specific type. This is in the package org.springframework.data.repository. Interface paging and sorting repository. Repository fragment to provide method to retrieve entities using the pagination and sorting abstraction. In many cases, this will be combined with CRUD repository or similar, or with manually added method to provide CRUD functionality. This is in the package org.springframework.data.repository. Interface JPA repository. JPA specific extension of repository. This is in the package org.springframework.data.jpa.repository. Here repository is connected to CRUD repository. CRUD repository is connected to pagination and sorting repository. Pagination and sorting repository is connected to JPA repository. Repository and CRUD repository and pagination and sorting repository belongs to Spring Data Commons. JPA repository belongs to Spring Data JPA. As an example, we are considering Spring Data JPA repositories in SQL databases. The following example shows a typical data repository interface definition. Spring Data JPA repositories are interfaces that you can define to access data. JPA queries are created automatically from your method names. For example, a city repository interface might declare find all by state string state method to find all the cities in a given state. For more complex queries, you can annotate your method with Spring Data's query annotation. Spring Data repositories usually extends from the repository or CRUD repository interfaces. If you use auto configuration, repositories are searched from the package containing your main configuration class, the one annotated with at enable auto configuration or at Spring Boot configuration down. The following example shows a typical Spring Data repository interface definition. Spring Data JPA repositories support 3 different modes of bootstrapping: default, deferred, and lazy. To enable deferred or lazy bootstrapping, set the spring.data.jpa.repositories.bootstrap mode property to deferred or lazy respectively. When using deferred or lazy bootstrapping, the auto-configured entity manager factory builder will use the context sync task executor, if any, as the bootstrap executor. If more than one exists, the one named application task executor will be used. When using deferred or lazy bootstrapping, make sure to defer any access to JPA infrastructure after the application context bootstrap phase. You can use smart initializing singleton to invoke any initialization that requires the JPA infrastructure. For JPA components, such as converters that are created as Spring Beans, use object provider to delay the resolution of dependencies, if any. Now we are considering Spring Data R2 DBC repositories in using R2 DBC. The following example shows a typical Spring Data repository interface definition. Spring Data R2 DBC repositories are interfaces that you can define to access data. Queries are created automatically from your method names. For example, a city repository interface might declare find all by state, string state method to find all the cities in a given state. For more complex queries, you can annotate your method with Spring Data's query annotation. Spring Data repositories usually extend from the repository or CRUD repository interfaces. If you use auto configuration, repositories are searched from the package containing your main configuration class, the one annotated with enable auto configuration or annotated with at enable auto configuration or at Spring Boot application down. The following example shows typical data repository interface definition. Now we are considering Spring Data MongoDB repositories in MongoDB in working with NoSQL technologies. You can take a JPA example from earlier and assuming that city is now a MongoDB data class rather than a JPA at entity. It works in the same way as shown in the following example here. Spring Data includes repository support for MongoDB. As with the JPA repositories discussed earlier, the basic principle is that queries are constructed automatically based on the method names. In fact, both Spring Data JPA and Spring MongoDB JPA, MongoDB share the same common infrastructure. You could take JPA example from earlier and assuming that city is now a MongoDB data class rather than JPA at entity. It works in the same way as shown in the following example. You can customize document scanning locations by using at entity scan annotation. Now we are considering Spring Data Neo4j repositories. You could take JPA example from earlier and define city as Spring Data Neo4j at node rather than JPA at entity, and the repository abstraction work in the same way as shown in the following example. Spring Data includes repository support for Neo4j. The Spring Data Neo4j shares the common infrastructure with Spring Data JPA as many other Spring Data modules do. You could take JPA example from earlier and define city as Spring Data Neo4j at node rather than JPA at entity, and the repository abstraction work in the same way as shown in the following example. The Spring Boot Starter Data Neo4j starter enables the repository support as well as transaction management. Spring Boot supports both classic and reactive Neo4j repositories using the Neo4j template or reactive Neo4j template beans. When project reactor is available on the class path, the reactive style is also auto-configured. You can customize the location to look for repositories and entities by using at enable Neo4j repositories and at entity scan respectively on at configuration bean. In an application using the reactive style, a reactive transaction manager is not auto-configured. To enable transaction management, you can define the separate bean. Now we are considering model. The Spring Boot performs all logic over the data of the database, which is mapped to a Spring Boot model class through JPA. As an example, we can consider this one. Now we are considering entity classes in JPA and Spring Data JPA in SQL databases. A typical entity class resembles the following example here. Traditionally, JPA entity classes are specified in a persistence.xml file. With Spring Boot, this file is not necessarily an entity scanning is used instead. By default, all packages below your main configuration class, the one annotated with at enable auto configuration or at Spring Boot application are searched. Any class annotated with at entity, at embeddable or at mapped super class are considered. A typical entity class resembles the following example. You can customize entity scanning locations by using at entity scan annotation. Additional members often include at one-to-many mappings. No args constructor required by JPA spec. This one is protected since it should not be used directly. And etc. Now we are focusing on database. The Spring Boot performs all logic over the data of the database, which is mapped to the Spring Boot model class through JPA. Here you can see Spring Boot CRUD RESTful API with Oracle database. Here you can see client interacts with Spring MVC application, and HTTP post you can see HTTP post, HTTP get, HTTP put, and HTTP delete. Through those, client communicate with the Spring MVC application. RESTful web services, Spring Data JPA, Hibernate and Hibernate frameworks are inside Spring MVC application here. Create, read, update, and delete are inside RESTful web services. Spring Data JPA interacts with Hibernate framework. Hibernate framework interacts with database. Spring MVC application is inside embedded Tomcat server. Embedded Tomcat server is inside Spring Boot application. As an example, we are considering data source configuration in configure a data source in SQL databases. For example, you may declare the following section in application.properties. Data source configuration is controlled by external configuration properties in spring.datasource.asterisk. For example, you might declare the following section in the application.properties. You should at least specify the URL by the spring.datasource.url property. Otherwise, Spring Boot tries to auto-configure an embedded database. Spring Boot can deduce the JDBC driver class for most databases from the URL. If you need to specify a specific class, you can use the spring.datasource.driver-class-name property. For a pooling database to be created, we need to be able to verify that a valid driver class is available. So we check that for that before doing anything. In other words, if you set spring.datasource.driver-class-name equal com.mysql.jdbc.driver, then that class has to be loadable. These are standard options that work regardless of actual implementation. It also possible to fine-tune implementation specific settings by their respective prefix. Spring.datasource.hikari.asterisk, spring.datasource.tomcat.asterisk, spring.datasource.dbcp2.asterisk, and spring.datasource.oracle ucp.asterisk. For instance, if you use Tomcat connection pool, you could customize many additional settings as shown in the following example. This will set the pool to wait 10,000 milliseconds before throwing an exception if no connection is available. limit the maximum number of connection to 50 and validate the connection before borrowing it from the pool. Now we are considering using JDBC template. Spring JDBC template and named parameter JDBC template classes are auto configured, and you can auto wire them directly into your beans as shown in the following example. You can customize some properties of the template by using spring.jdbc.template *properties as shown in the following example. The named parameter JDBC template reuses the same JDBC template instance behind the scenes. If more than one JDBC template is defined and no primary candidate exists, the named parameter JDBC template is not auto-configured. Now we are considering creating and dropping JPA databases. For example, to create and drop tables, you can add the following line in your application.properties. By default, JPA databases are automatically created only if you use embedded database, H2, HSQL or Derby. You can explicitly configure JPA settings by using spring.jpa.*properties. For example, to create and drop tables, you can add the following line in your application.properties. Hibernate's own internal property name for this, if you happen to remember it better, is the hibernate.hbm2ddl.auto. You can set it along with other Hibernate native properties by using spring.jpa.properties **. The prefix is stripped before adding them to the entity manager. Now we are considering using DSL context in using JOOQ. To use DSL context, you can inject it as shown in the following example. The Fluent API offered by JOOQ is initiated through the JOOQ.DSL context interface. Spring Boot auto-configures a DSL context as a Spring Bean and connects it to your application data source. To use DSL context, you can inject it as shown in the following example. The JOOQ manual tend to use a variable name create to hold the DSL context. You can then use DSL context to construct your queries as shown in the following example. Now we are considering using R2 DBC. For example, you might declare the following section in application dot properties. The interface connection factory options builder customizer callback interface that can be implemented by beans wishing to customize connection factory options via a connection factory options builder. Connection factory options dot builder whilst retaining default auto configuration. This is in the package org.springframework.boot.autoconfigure.r2dbc. The reactive database connectivity R2DBC project brings reactive programming APIs to relational databases. R2DBC's io.r2dbc.spi.connection provides a standard method of working with non-blocking database connections. Connections are provided by using a connection factory. Similar to a data source with JDBC. Connection factory configuration is controlled by external configuration properties in JDBC spring.r2dbc.asterisk. For example, you might declare the following section in application.properties. You do not need to specify a driver class name since Spring Boot obtains the driver from R2DBC's connection factory discovery. At least the URL should be provided. Information is specified in the URL takes precedence over individual properties, that is name, username, password, and pooling options. To customize the connection created by the connection factory, that is set specific parameters you do not want to or cannot configure in your central database configuration. You can use connection factory option builder customizer at Bean. The following example shows how to manually override the database port while the rest of the options is taken from the application configuration. Now we are considering connecting to Redis. In working with NoSQL technologies. The following listing shows an example of example. You can inject an auto-configured Redis connection factory, string Redis template, or vanilla Redis template instance as you would any other Spring Bean. By default, the instance tries to connect to a Redis server at localhost colon 637279. The following listing shows an example of such a bean. You can also register an arbitrary number of beans that implement Lettuce client configuration builder customizer for more advanced customizations. Client resources can be also customized using client resource builder customizer. If you use JDIS client configuration builder customizer is also available. Alternatively, you can register a bean of type Redis standalone configuration, Redis Sentinel configuration, or Redis cluster configuration to take full control over the configuration. If you add your own @bean of any of auto-configured types, it replaces the default except in the class in the case of Redis template when the execution is based on the bean name Redis template, not its type. By default, a pool connection factory is auto-configured if commands pool2 is on the class path. Now we are considering MongoDB. The following example shows how to connect to MongoDB database. To access MongoDB databases, you can inject an auto-configured org.springframework.data.mongodb.mongo database factory. By default, the instance tries to connect to a MongoDB server at mongodb //localhost/test. The following example shows how to connect MongoDB database. If you have defined your own Mongo client, it will be used to auto-configure a suitable Mongo database factory. The auto-configured Mongo client is created using Mongo client settings bean. If you have defined your own Mongo client settings, it will be used without modification, and the spring.data.mongodb properties will be ignored. Otherwise, the MongoDB client settings will be auto-configured and will have the spring.data.mongodb properties applied to it. In either case, you can declare one or more Mongo client settings builder customizer beans to fine-tune the Mongo client settings configuration. Each will be called in order with the Mongo client settings.builder that is used to build the Mongo client settings. You can set the spring.data.mongodb.uri property to change the URI and configure additional settings such as replica set, as shown in the following example. Spring Data MongoDB provides a Mongo template class that is very similar to in its design to Spring's JDBC templates. As with the JDBC template, Spring Boot auto-configure a bean for you to inject the template as follows. Now we are considering connecting to a Neo4j database in Neo4j. The following example shows how to inject a Neo4j driver that gives you access to, among other things, to a session. To access a Neo4j server, you can inject an auto-configured org.neo4j.driver. By default, the instance tries to connect to a Neo4j server at localhost /7687 using the Bolt protocol. Following example shows how to inject a Neo4j driver that gives you access, among other things, to a session. You can configure various aspects of the driver using spring.neo4j.asterisk properties. The following example shows how to configure URI and credentials to use. The auto-configured driver is created by using config builder. To fine-tune its configuration, declare one or more configuration builder customizer beans. Config builder customizer beans. Each will be called in order with config builder that is used to build the driver. Now we are considering connecting to Elasticsearch using REST client in Elasticsearch. You can use spring.elasticsearch.asterisk properties to further tune how the clients are configured, as shown in the following example. Elasticsearch ships two different REST clients that you can use to configure cluster. The low-level client from the org.elasticsearch.client REST client module, and the Java API client from core.elasticsearch.clients colon Elasticsearch Java module. Additionally, Spring Boot provides support for a reactive client from the org.spring framework.data colon Spring Data Elasticsearch module. By default, the clients will target localhost colon 9200. You can use Spring .elasticsearch .asterisk properties to further tune how the client are configured as shown in the following example here. Now we are considering connecting to Cassandra. In Cassandra, generally you provide a key space name and contact points as well as local data center name as shown in the following example. You can inject an auto-configured Cassandra template or Cassandra SQL session instance as you would with any other Spring Bean. The spring.cassandra.asterisk properties can be used to customize connection. Generally, you provide a key space name, contact points, as well as the data center name as shown in the following example. The following code listing shows how to inject Cassandra bean. If you add your own @bean of type Cassandra template, it replaces the default. Now we are considering connecting to Couchbase in Couchbase. Generally, you provide the connection string, username, and password as shown in the following example. You can get a cluster by adding the Couchbase SDK and some configuration. The spring.couchbase.asterisk properties can be used to customize the connection. Generally, you can provide the connection string, username, and password as shown in the following example. You can also possible to customize some of the cluster environment settings. For instance, following configuration changes the timeout to open a new bucket and enables SSL support. The following example shows how to inject Couchbase template bean. Now we are considering connecting to an LDAP server in LDAP. To connect to a LDAP server, make sure you declare a dependency on the Spring Boot starter data LDAP starter or Spring LDAP core, and then declare the URLs of your server in your application.properties as shown in the following example. If you need to customize connection settings, you can use spring.ldap.base and spring.ldap.base environment properties. LDAP context source is auto-configured based on these settings. If dir context authentication strategy bean is available, it is associated to the auto-configured LDAP context source. If you need to customize it, for instance, use a pooled context source, you can still inject the auto-configured LDAP context source. Make sure to flag your customized context source as at primary so that the auto-configured LDAP template uses it. Spring Data include repository support for LDAP. Also, you can also inject an auto-configured LDAP template instance as you would with any other Spring Bean as shown in the following example. Now we are considering connecting to Influx DB in Influx DB. Spring Boot auto configures an Influx instance and provided the Influx DB Java client is on the class path and the URL of the database is set as shown here. If the connection to Influx DB requires a username and password, you can set the spring.influx.user and spring.influx.password properties accordingly. InfluxDB relies on OK HTTP. If you need to tune the HTTP client InfluxDB uses behind the scenes, you can register InfluxDB OK HTTP client builder provider bean. If you need more control over the configuration, consider registering InfluxDB customizer bean. Now we are considering configuring data source programmatically in configuring data source programmatically in Spring Boot. The simplest way to accomplish this is by defining data source factory method and placing it within a class annotated with at configuration annotation. The annotation the class data source builder txtend data source convenience class for building a data source provide a limited subset of the properties supported by a typical data source as well as detection logic to pick the most suitable pooling data source implementation. This is in the package org.springframework.boot.jdbc. Now if we stick with the Spring Boot's automatic data source configuration and run our project in its current state, it will work here. Here we are considering the situation. The Spring Boot will do all the heavy infrastructure plumbing for us. This includes creating an H2 data source implementation, which will be automatically handled by Hikari CP, Apache Tomcat, or Commons DBCP, and setting up an in-memory database instance. Additionally, we won't even need to create an application.properties file, as Spring Boot will provide some default database settings as well. At times we will need a higher level of customization, so we will have to programmatically configure our own database implementation. The simplest way to accomplish this is by defining data source factory method and placing it within a class annotated with at configuration annotation. In this case, we used the convenient data source builder class, a non-fluent version of Joshua's block builder pattern, to programmatically create our own data source object. This approach is really nice because the builder makes it easy to configure a data source using some common properties. It uses underlying connection pool as well. As an error example, we can consider this error: fail to configure a data source URL attribute is fail to configure a data source URL attribute is not specified and no embedded data source could be configured. Reason: fail to determine the suitable driver class. By design, the Spring Boot auto configuration tries to configure the beans automatically based on the dependencies added to the class path. And since we have the JPA dependency in this particular case in our class path, the Spring Boot tries to automatically configure a JPA data source. The problem is that we haven't given Spring the information it needs to perform auto configuration. For example, we haven't defined any JDBC connection properties, and need to do some need to do so when working with external databases such as MySQL and MS SQL. In other hand, we won't face this issue with in-memory databases such as H2, since they can create a data source without all the information. There are two ways of approaching the solution: defining that the data source using properties, or defining the data source programmatically. Here we are considering properties approach. Since since the issue occurs due to the missing database connection, we can solve the problem simply by providing the data source properties. First, let's define the data source properties in the application.properties file in the project here. This is end of my presentation. Thank you very much for watching it.